Hey guys, Francois here for Peel3D. Now in this video tutorial, I will show you a first glimpse at the Peel3D interface, how to calibrate your Peel3D scanner, and how to set your parameters prior to scanning. This here is the Peel3D software interface, and up here you have the toolbar. Now toolbar is interactive, so it will change based on where you stand in your workflow. On the right hand side of the screen here you have the viewer. This shows the current status of your scan and your project. You can toggle the contextual help on and off using the question mark sign here on top of the screen. Now as the name implies, it provides contextual help based on the function that's currently selected. And finally, on the left-hand side of the screen here, you have the side menu. This is where you set your scanner parameters prior to starting your scan. Scanner calibration is recommended every once in a while, especially after carrying your scanner on long distances or when accuracy of the model really matters. It's a very simple procedure and it only takes a few seconds to do. Take the calibration plate out of your carrying case located under the protective foam. Open the box and lay the plate flat on a surface. Place your Peel3D scanner above the plate and press the trigger. The white square is a positioning reference for your scanner, and the green one is the requirement. Align the white square with the green square. Once the first position is reached, slowly move the scanner away from the plate until all positions have been captured. You are now ready to scan. Before starting a scan, it's always a good practice to set the scan parameters from the side menu. Here's a bit more information on what the different functions do. In the scanner parameters, you have the detection mode. Here you can choose between uniform or textured. Uniform will provide better looking surfaces, while textured will perform better on noisier surfaces or with objects with higher contrast. Here's a pro tip. Start by trying to scan your part in uniform mode. If the surface is too difficult to scan, switch to textured. Keep in mind that you can always change the scan mode as you're scanning. You can also change the shutter settings. A shutter is the length of time the camera sensor is exposed to light. A short time will be ideal for pale surfaces but might result in underexposed images on darker surfaces. A longer setting will work better on darker surfaces but might result in overexposed images on light surfaces. By default, the automatic shutter will be checked, and the software will automatically try to adjust it as you go. You can also get a taste as per what the scanner sees by pressing the Scanner Config button. Now here the yellow pixels are ideal, the red ones are saturated, and the gray ones are underexposed. Using this interface, you can tweak the shutter setting to find the ideal compromise. Here's a pro tip. A default value between 4 and 5 milliseconds usually works great with about any surface except the very dark ones, in which case you'll want to use a value of 8 milliseconds. In the positioning parameters, you can set the specific parameters related to how the scanner is positioned in space. By default, all these options will be turned off. Targets required will not use the geometry of the object for positioning at all. It will solely rely on targets. It can be useful to ensure the maximum accuracy of the product, but it requires the scanner to see at least 4 targets at all times. Semi-rigid positioning will provide you with looser tolerances for positioning and will tolerate a bit of movement. This is very useful, especially if you plan to scan parts of the human anatomy. The Show Positioning Status checkbox will provide you with useful information when your scanner struggles at positioning. The arrows displayed on the surface will show you the slip direction of the part you're scanning. Yellow is slippery but acceptable, and red will prevent the scanner from capturing data as they could be incorrectly positioned and corrupt the scanned data. This is something you will often see on flat or smooth area. Using the positioning markers supplied with the scanner will allow you to scan these areas without a problem. Additional pictograms will be displayed on the upper right corner of the viewer and provide you with additional information. This means there's not enough data visible. This means the frame currently observed is impossible to position on the model. This is a recommendation to apply one or a few targets. And finally, this means a positioning ambiguity on the part. In the scan parameters, you can set the resolution. This defines the size of the triangles that are going to be used to reconstruct the scanned surface. A smaller value will show you more details, but require more computer resources. Here's a pro tip. If you wish to use a resolution under 1 mm, start by scanning your part with a resolution of 1 mm. Trying to scan with a resolution under 1 mm will likely be too demanding for your computer and slow down the scan process too much. Once your scan completed, change it to the desired resolution. The few parameters left are adjusted with sliders and have a value from 0 to 100. The optimized scan mesh is an intelligent smooth that's going to keep the edges sharp with smooth, flatter surfaces. It's very useful when scanning design surfaces. The decimate scan mesh will reduce the amount of triangles based on surface curvature. The autofill holes will automatically fill small holes based on their size. And finally, the remove isolated patches will remove floating patches not connected to your main object. That's it. You're now ready to start scanning. And remember that you can always save your parameters as default, and that you can change the parameters on an existing session once the scan is completed.